Well, it's not working in prod. Indeed, it's not working in prod. Well, it's not my problem. It works just fine on my machine and on the dev server. Well,
I told you all systems are ISOs. And if it's working in dev, it's working in prod.
it's ISO?
Oh, yeah. Essentially, I mean, pretty much almost.
Almost? What do you mean, almost?
You know, there's maybe a very small gap in minor versions. And for some plugins. Nothing particularly important.
All right. That video never gets old.
Brings
All
back
right.
memories.
Yeah. Hello, everybody. Welcome to today's show. We've got some folks on live. If you want, sound off on chat. I'd love to see where everybody's coming from in the world. We have a very big community. It's always cool to see where people are tuning in. But today's show, we're going to be talking about BuildKit, BuildKit, BuildKit. And today I got a good friend of mine, Jerome, on with us. Jerome, how are you?
Hello, pretty good. I just wrapped up the week of training, so it's almost the weekend for me. So that's a good way to almost start the weekend.
Yeah, well, tell everybody who you are and what you do.
So I'm Jerome Petazzoni. I was, one of the OGs at Docker. I was at Docker back when it was .cloud, so pre-Docker era, back in 2011. I like to say that I was running containers in production and before it was cool, so that probably makes me like a container hipster. And now, after 7 years at Docker, now I'm doing training around Docker and Kubernetes. I've been doing that since 2018 and been pretty busy at it. So yeah, that's me in a nutshell.
Awesome. Yeah, we were talking about that little clip at the beginning. Couldn't place it right away. Probably 2015?
Probably. I in my mind, it's not the first DockerCon, but maybe the second one, which would be like around that time frame.
Yeah. It's still relevant today. I still love it. Well, awesome. Well, thanks for joining us. I really wanted to have you on because I wanted to talk about BuildKit, BuildX, all the wonderful things, Compose, all those great things. And you were the man to talk to. You wrote it all. You developed it all. No, I'm just kidding.
Not really. I used it. No, I feel like when I was at Docker and folks were already working on BuildKit back then, it was a little bit like peeking in the secret lab where all the cool stuff happens. And I remember seeing demos from Arnaud, notably like Arnaud Porterie, who was leading the open source team, the core team back then. And I was like, wow, this thing is going to be really cool. And earlier this year, when I saw that BuildKit was becoming the default backend for Docker build on Docker Desktop, I was pretty excited because I feel like this had been at least maybe 3-4 years in the making. So yeah, now everyone is going to use BuildKit, so that's cool.
Yeah. Oh, I so want to jump into all the goodness of BuildKit, but why don't we do that? You want to just jump right into it and start sharing?
Sure.
Awesome.
Yeah.
Okay, cool.
Okay. So I think this thing says that I'm sharing my screen, but maybe you have to put it on stage or something. Yes,
there we
go.
It.
Yeah. So we were looking for a nice catchy title, and all we could find was BuildKit has an homage to Steve Ballmer's developers. So today I have 3 words for you: BuildKit. And we were chatting with Peter just before the show began about me smashing a chair on live, but we decided to not use that idea. Okay, so I'm Jerome Petazzoni, but I already said that, so I can kind of jump right in. I made a few slides because I'm kind of a slides person, but I want to show you mostly demos. So the slides are here just so that I can remember what I want to tell you about. First, I'm going to tell you about Docker build version numbers, and that's something that I completely made up, by the way. I don't think anyone else is talking about Docker build that way. But in my mind, when I think about Docker build, there is Docker build version 1, version 2, version 3, and this is what I mean. For me, Docker build version 1 is what we had in 2013. So we have a Docker file, and you say, hey, I want to build something cool based on Ubuntu, and then you install a bunch of packages and copy your source code, etc., and boom, you get an image. And you get an image, but lots of people notice that you get a really big image sometimes. Like we've all done that. You build a hello world in C, and you're like, why is my image 900 megabytes when the binary is like 16 kilobytes? I feel like I've been played. And so eventually we had multi-stage builds. So here is an example here where, actually I screwed up that example. Normally we should have another from line here, my bad. But multi-stage builds are kind of, for me, it's Docker build 2.0, because now we can have these super nice optimized images. So that's great. Yeah, like I've put on that slide like 100x size reduction, because yes, that happens, especially with compiled languages. As soon as you put some C or some Go or some Rust, you end up with a huge compile image, but the binary itself is tiny, and then multi-stage builds, yay. So just for folks who want to explore, like small images, how to make super optimized images, I have this repo here, JPetazzo Minimage, where I have, 20 plus something examples of multi-stage builds to show, like in Python, in Ruby, in C, in Go, etc., the kind of stuff we can do with multi-stage or with Alpine as well. Anyway, and a little bit of self-promo. I have this series of blog posts about image optimization as well, and they are available both in English and in French as well, so yay. Okay, now there is Docker Build 3.0, and Docker Build 3.0, again, not an official version number, just the way I think about it. Docker Build 3.0 looks to be exactly the same as 2.0, because yes, that's the same thing, except now we changed the backend to have BuildKit. And to me, it's a little bit, if we think about a car, when you go to a classic old combustion engine thing to a Tesla, and you still have like a steering wheel and you have pedals to make it go fast and whatever, except the engine is completely different, completely remade. For me, that's basically Docker Build 3.0 powered by BuildKit. That's the idea. All right. Why do we need a new Docker build? Well, because we got a lot of mileage from the original Docker build. But I think BuildKit is probably what the team would have done if they had a crystal ball and could have predicted how people will use Docker 10 years later. So, but of course you can never do that. You ship it and then you have to maintain it, and then it's too late. But eventually you get the opportunity to redo the backend, and that's BuildKit. All right. Okay. The BuildKit sales pitch, whatever. We don't care about that. So before I dive into the demos, couple of things. As I was saying in the beginning, like BuildKit has been around for quite a while. This is not some shiny new beta experimental stuff. I think it's been around since at least 2017. And at least since 2018, you could enable BuildKit with an environment variable for your Docker builds. And now I realized earlier this year that if you're using Docker Desktop, which I suppose is the case for most folks using a Mac or Windows, now BuildKit is the default builder. All right, so I want to show you like different features, like how, like the difference, like before, after with the plain build and with BuildKit. So this is a kind of textbook example so this is a Docker image where I have my Swiss Army knife of cloud stuff. So I have the Docker CLI, I have kubectl, I have Terraform, and I put all that in a Docker image. And I'm using multi-stage here. And so I have one stage for each binary so that I can download each binary. And at the end, you can see that I'm just copying the binary from each of these 3 stages. And so if I go to my machine here and I go to this first example, by the way, all the examples that I'm going to show you, I just pushed that to a Git repo just before we started the show. So I think the URL will be shared as well. So if you wonder where can I find these Docker files, etc., it's all on a public GitHub repo. Okay, so that's the first Docker file that I want to build. That's the one I was showing you earlier. So if I try to build without build kit, like old school, so Docker build kit 0, Docker build dot dash dash tag tools dash dash no cache. So let's see how long it takes. So first, the thing you can do is that the old school builder is very linear. It's looking like step 1, step 2, step 3. It takes every line of the Docker file and it's kind of moving onwards with that. Now it's downloading kubectl, then it's going to download Terraform, like one at a time. Right. So that's nice because I think it's relatively simple to implement. Actually, I've seen folks re-implement part of the Dockerfile syntax with shell functions, which was pretty nice. And this took about 30 seconds. Okay, great. Now let's do the same build, but with BuildKit. So I just have to flip that environment variable here. So first you can see, like the output is a little bit different. You can see here that it's downloading the things in parallel because instead of doing that very linear process, it kind of realizes, hey, I can actually run these things in parallel, like simultaneously. And then they kind of join at the end and we end up with a 15 seconds build. Sure, 30 seconds to 15 seconds, it's not a huge difference if we think about 15 seconds, but that's still like a 100% speed improvement. And as you can imagine, if you do that on a bigger, like more serious build, that's going to help a lot. If you need a more concrete example, think about if you have some React app where you have some Webpack working on a bunch of JavaScript, and then you have a bunch of CSS, and then you have maybe some assets that also need to be mangled somehow. If you can do all that in parallel, that can cut the build time significantly. Yeah. Okay.
And especially if you're doing that multiple times a day, right?
Absolutely. Yeah, absolutely. Totally. Yeah, to me, the whole point of reducing the build time, it's not just to say, oh, today I saved 15 seconds. It's because I do that like dozens, hundreds of times every day. And that was kind of the big point of Docker in the beginning. Yeah, it's instead of shipping one time per week or whatever, we could ship multiple times a day because the whole cycle, the whole iteration was shorter. Right. And so just as a little example, if I Docker run these tools, it's going to kind of confirm that I have the Docker CLI, I have the kubectl CLI, I have the Terraform CLI, and HashiCorp shipped a new version of Terraform since I built this together just last week. So it's complaining that now we have 105, but never mind that. Okay. So that was a first little example of build kits like with this parallel thing. Right. So now another example, which I also found super interesting because, Pierre was joking about the fact that I worked on that code, but I didn't. My last contribution to the Docker engine was in, I think, late 2013. I'm guilty of the privilege flag that we wanted to have Docker in Docker and stuff like that. And even that, to be honest, I did the first kind of proof of concept, and then without Michael Crosby, that code would never have made it. So, anyway, one thing that I found really fascinating is when I was thinking about the whole build process, I was thinking it could be nice if when we do copy, Docker could somehow pull the files that we need to copy. Instead of, when we do a Docker build, the first line is always sending build context, and it's kind of sending the entire directory to the Docker engine. Well, with BuildKit, this is no longer the case, and I haven't checked exactly how it works but let me show you this little demo here. Okay, so in this demo, let's pretend that I have a very messy Git repo with a bajillion things in it. And so to emulate that in this directory, you can see that I have 4 dataset files of 1 meg, 10 megs, 100 megs, and 1 gig. And what happens if we try to build? Okay, so let's build without BuildKit first. And I don't even need to no cache or whatever here. Well, let's put the no cache anyway, just to be sure. Whoops, my bad, excuse me. Okay, so I have this, and in the Docker file, I'm just doing something super simple. I copy the big data set, which is 100 megs, into my container image. So pre-BuildKit, without BuildKit, what happens is that we are sending the whole build context to the Docker daemon, so 1 gig that we send there. Now with BuildKit, as you can see, we did not send the entire build context. Instead, there is some kind of pull mechanism. When we do a copy, only at that time, the Docker engine will somehow communicate back to the client to say, hey, I need this file, these directories, etc. So that's pretty cool because, okay, in that case, we go from 6 seconds to 1.7 seconds. So again, if we think in absolute terms, we saved 3-4 seconds. So we could say, who cares? But we also divided by 3, almost 4, the build time, which is kind of exciting. And this is really for you if you have this huge repo and you only need some bits of that repo to build your image, and you're fed up with having to wait maybe 20 or 30 seconds at the beginning of the build just to send the entire repo to the Docker engine. So that's
I don't know how many I don't know how many times I've done that, Jerome, and then I got to go back and put my ignore file back in, right, when I'm using BuildKit.
Totally.
Sit there and watch it. And I just sent 4 gigs to the engine. What did I send there? Why?
Exactly. And even if you use Docker ignore, because yes, you can use Docker ignore and that's great, but that gets tricky if you have multiple builds from the same repo and you don't need the same ignore files. Docker ignore only gets you so far in this process. So it's really great to have this. Okay. So that was, I would say, just these 2 features that I showed you, that's what I would use to convince, you developers to switch to BuildKit. I'm going to show you a few more demos after with support for multiple platforms and support for Kubernetes builds. But for now, I just want to talk to my fellow developers working on their local machine. So imagining that you are super excited about BuildKit and wonder how to use it. Well, if you're using Docker Desktop, you don't have anything to do because it's enabled by default since, I don't know exactly when, but at least since March or something like that, I think. And if
remember the
you,
exact date, but yeah.
yeah,
Yeah.
and if you are on Linux, like I am, then you can use that environment variable like docker build kit equal 1 and done. Now you have build kit, so that's nice. Okay, now we're going to talk to the folks running on orchestration platforms. Like I'm no longer talking just to the developers now, but also to the folks who have to deploy that stuff to production, and building on Kubernetes. So as I was saying earlier, the original Docker build is pretty elegant in the way, in the sense that you can implement it with just Docker run and Docker commit, but it requires to run the Docker engine. And as much as the Docker engine is awesome in a dev environment, there is an increasing a sizable crowd telling us, well, maybe I don't want to have the Docker engine on my clusters. Maybe I want to have Containerd, for instance, which is the backend used by Docker to run the containers. Another thing is that even if you use Docker as your engine in Kubernetes, when you run a Docker build, that Docker build is going to use, I'm going to say, some kind of shadow resources in a way. How can I try to explain that? It's a little bit as if you had like your Kubernetes cluster is like your kitchen when you're cooking stuff. And when you do a Docker build, it's basically like making a chemistry experiment or something like that. And you're like, well, I don't want to do some chemistry experiment in my kitchen. I want to have something separate. So that's the motivation here. Let's try to have a builder that kind of plays nice with Kubernetes, with Nomad, maybe even in some ways with Docker Swarm. How were we doing before? Well, we had stuff like Docker in Docker. So as I was saying earlier, like I'm responsible for doing that privilege flag that let us do Docker in Docker, which was super cool. Because we could use that meme like, yo, dog, I know you like containers, so I put containers in your container so that you can run stuff, etc., etc. But the problem with Docker in Docker is that you need privileged containers. Now there is a lot of work that has been done to make Docker in Docker work without privileged containers. For instance, there is all the work done on rootless Docker. We also have very innovative runtimes like Sysbox, for instance, which basically gives you a kind of privileged container, but which is not privileged. I mean, you can do all the stuff you can do in a privileged container, but it doesn't give you full open bar access to the machine. Another thing you can do is bind mount the Docker socket. So basically, instead of having containers in containers, you kind of have containers next to containers. We also have other super kind of creative ways to build containers. Just two that I know of, Bazel and Nix. So these things are amazing, but they are also not super easy to learn and to use. So if you are a team of 500 developers and you really want to have high velocity, etc., sure, you can have like a couple of folks dedicated to maintain a Bazel or Nix build toolchain. But if you are a team of 10 folks, maybe you don't want to have 3 of them dedicated to maintain your tooling. That would be a little bit overkill. Right. We also have a bunch of builders that came out since then. For instance, Jib and Co. So Jib for Java, Co for Go. These things are also super magic because they will build Java images and Go images. I mean, container images, but for Java and Go stuff. Super easily, nice images. The only drawback is that if you're not doing Java or not doing Go, that doesn't help you. Then we have Buildah, which is basically folks who decided, okay, we need to have a new, completely new kind of paradigm to build Docker images. There is Kaniko. I want to special shout out to Kaniko because it's the first builder that I could use on Kubernetes and that could run without special privileges or anything. You know, you kubectl run blah blah blah, and it would build things. And I think the first time I saw that in action was 2018 or something like that, but it might be even older than that. Now, the downside of that is with caching. Now, just to be honest and clear here, maybe that got better since then. But back then when I was playing with it, one thing we like with Docker build is this caching thing. Okay, the first build takes a while, but the following builds are so fast. And with something like Kaniko, you don't have that caching out of the box. And even if you want to have it, in my experience, you basically, the builder is entirely stateless. So when you want to have caching, at the beginning of the build, you pull the cache, you build things, and then you push back the cache. And so this pull and push business still takes time. And with BuildKit, it feels like we have the best of both worlds because we have caching, but we don't need to pull and push that cache. The cache is going to live in the BuildKit builder and stay there. So I feel like I need to run a little demo here. Let's see. Yes, that's here. Okay, let's try that. 3 Kubernetes. Yes. Okay. First, I need a Kubernetes cluster. So I'm going to use kind create cluster. I'm still waiting for Docker Desktop to be available on Linux. Wink, wink, nudge, nudge.
It's coming. It's coming. We get asked that a ton.
And yesterday I was attending there was a meetup by the folks at Rancher when they were showing like Rancher Desktop. And so I was thinking, okay, are they going to have Rancher Desktop on Linux? So I was thinking maybe that's going to give an incentive to the Docker Desktop team, but no, Rancher Desktop doesn't support Linux yet. So we'll see who's the first to bring Linux support to the desktop.
We've been. I would say too, while we're waiting, to go to the roadmap. That's where all of our features, functionality, everything we're working on, you can find on the Docker roadmap. And yeah, we have a card in there. Are they called cards? I forget what they're called in GitHub, but yeah, we have a card in there around desktop on Linux, right? It's a huge ask from our our community. Be super helpful, right? Even though you can install everything and do, you just get a Kubernetes install set up nice and easy for you. Things just work, right?
Yeah,
100%.
Though to be fair, I can't complain because with stuff like Kind and Key3D and Minikube, once you have everything set up, it's also super nice. I'm really in love with the fact that with Kind, for instance, or Key3D, I can even have multiple clusters running on my machine very easily and for a pretty reasonable amount of resources. But okay, so now I have a Kubernetes cluster. Okay, it's a 1 node cluster, so nothing fancy. And okay, so that's okay. Now first I need to, no, that's done. Docker buildix ls. Okay, I need to remove this, excuse me. There we go. Okay, good. So we initialize that with this command. So we do docker buildx create. So it's basically I'm creating a new driver, a new builder instance. I say this is going to use Kubernetes. I don't even need to give a name actually, --use. So that creates a builder. So this did not really do anything to my Kubernetes cluster so far. It just created like an entry on the Docker side. And if I look here, I still have nothing on the Kubernetes cluster. But now if I do triple checking my command here, okay, so Docker build dix build. I'm going to build my little tool image, the one with Docker, kubectl, and Terraform, -- load. So we have this thing that says like booting build kit. So what it does is that it's creating a Kubernetes deployment, which is going to create a pod. And that's in that pod that the magic will happen. And the nice thing is that the build cache will be in that pod. So there we go. It should take just 15 seconds total. And then it's loading the result of the build in my Docker engine. There we go, importing to Docker. Perfect. So we have the niceness of the build, of the cache, excuse me. Like if I run that again, boom, it took, what, 1 second maybe? So great. But if so that's the pod, right? The pod with build kit and with the build cache. And if I do something horrible to that pod, there we go. If I try to, okay. So first, since that's a Kubernetes deployment, Kubernetes is going to recreate a replacement pod immediately, but you can see it's not the same pod anymore, right? That was the old pod, that's the new pod. And if I try to build again, so you can see that the cache is gone, but there was no other problem, other than that. So to me, that's great because I don't need to configure this pull and this push and this whatever. I don't need to do something special with my registry. I just get caching out of the box with very little effort. So I really like this, and I don't know exactly who made that, but thanks. That's awesome. All right. Next. The next thing that got me really excited with BuildKit is working with other platforms like non-Intel 64. As you probably know, if you have, for instance, Raspberry Pis, or if you have, Mac M1, like the new Apple Silicon thing, then you probably know that the world is not only made of Intel 64-bit CPUs, and so when we have ARM CPUs, for instance, or Intel 32 bits, or other platforms like Spark, RISC, the S390, which is the IBM mainframes, etc., then you need to care about that. And I'm going to show you 2 Docker files. Okay, so this is my version of the Docker file. So this is when I do training. I have this container image where we have a bazillion tools. So we have Docker Compose, kubectl, Stern, Helm, HTTPing, etc. Like basically each time I stumble upon a cool tool, I just add it to that image. And so we have a Docker file like that. Now, I started working on this like years ago, and back then I didn't care about other architectures, and it shows. If we look here, we can see like AMD 64 hard-coded, Linux AMD 64 hard-coded, x86 64 hard-coded. don't be like Jerome. Don't hard code the architectures and etc. all over the place. Instead, be like Brett. Brett Fisher, fellow Docker captain. We collaborated on some Udemy courses on Kubernetes. And we worked on Docker training and workshops back in the days. And as it happens, some students of Brett asked him, "Hey, can we have that nice little image, but for probably like Apple Silicon?" And so Brett rewrote that Docker file to have a nice little case statements like this. We check, okay, what kind of platform are you building for? And depending on that, we're going to download different binaries, different programs. And this is what it looks like, each time. Okay, so first, how does that work? In your Docker file, you put arg target platform. And automatically then BuildKit is going to set that target platform to a special value. So it's going to be, for instance, Linux/AMD64, or I think it's Linux/ maybe i686, Linux/ARM8 perhaps. And well, actually we have the values here. Yes, no, Linux/ARM64 and Linux/ARM/v7. If you wonder where these values come from, like for instance, if you wonder why did they call this ARM64 and this ARM-v7 instead of ARM32, this comes from the Go OS and the Go Arch variables. So it's not Docker folks or BuildKit folks who decided to do that. They follow the convention of the Go toolchain. So that's the reason. And then as you can see, you use that to know what binary, which binary you need to download. Now, in some cases, for instance, if you look at these lines here, here I'm installing K9s and Popeye. K9s is this super cool BBS style tool for Kubernetes. It gives you a view of your cluster like this. So for that, as you can see here, the downloads follow a specific convention. You see here, I'm using uname-s and uname-m. These are commands that give you the operating system and the architecture. If I run these commands on an ARM machine that I have here, it's going to show us like AArch64, for instance. So what that means is that if you're downloading something where the releases are named properly, so to speak, like properly, then you don't need to put a case switch. You could put directly like uname-s, uname-m, and that would work. Same thing if you have, for instance, let me show you an example. All right, no, sorry, not that one. It's that one. This is an example of rewriting my little Docker file of earlier, the one that was using Docker CLI, kubectl, and Terraform. And so now it's using this target platform variable. So sometimes, if you are lucky, you can use the target platform variable, or you can use that uname-m shell function, for instance, and that will give you the right file to download. But sometimes you will have a program where the Intel download is going to be called like, I don't know, AMD64.zip, let's say, and the ARM 64-bit could be, let's say, AArch64. And when you have that, how can I explain that? It's a little bit like if we had color names, and on one side you have like red, green, and then you expect that the third one is going to be blue, But no, instead of blue, they're going to put like bleu, like in French or something like that. And so here, I would hope that everyone putting up releases is going to try to be consistent, in the convention that you use. So basically, if you use AMD 64, then I guess you should use ARM64, I think. If you use x86-64, wow, that's a tough one.
Say that again.
Then it should be ARM64, for consistency. If we don't have consistency, then we end up having to do stuff like this, with case statements and having to spell out everything. But yeah, anyway. So back to BuildKit and the way that it supports multiple architectures. We have this target platform build variable, which is great because you know what you are targeting. And we also have build platform, which indicates where you are running right now. You might wonder, what's the point of having these two variables? Well, this is because sometimes you might be on an Intel machine, but you might be building something for a Raspberry Pi or for Apple Silicon or something like that. And in that case, it could make sense to download a cross compiler for the build platform, but targeting the target platform. Okay, if you're new to this whole cross compilation business, you can safely ignore this last couple of sentences. But later, if you have to dive into that and you go back to that, I promise it will make sense. So yeah, example, transforming this first Docker file into that new Docker file. And so you can see here we had like x86-64, which turns into uname-m. So that's nice. Here we had Linux/AMD64. We transformed that into target platform. And here we had Linux_AMD64. And so we used that fancy shell substitution to get target platform, but replace the slash with underscores because we really want to be fancy. And that way we don't have to use a case switch because kudos to the folks at Docker and the folks managing the releases for Kubernetes and the folks at HashiCorp. All these folks use kind of proper naming for the different architectures, and so it just works. Awesome.
Yep.
Now, yeah, that's basically what I was trying to explain. Now I have a really weird demo for you. This demo is the one that I called Babel, like the Tower of Babel, where everyone is speaking different languages and we're doomed. What does that look like? Okay, so here we are using from with a -- platform. So basically, what I'm doing here is that I'm building an image with 4 versions of BusyBox. I have BusyBox for Intel 64 bits, Intel 32 bits, ARM 64 bits, ARM 32 bits. So to achieve that, I'm having it's a kind of multi-stage, if you will. So I define like 4 aliases for these images. And then I copy BusyBox from these different images to my final image. And then when you run the container, it will try to execute that BusyBox just to see if it works. Okay, yeah. I have the exact commands I need to run so that I don't mess up. Well, I think I messed up because I need to make sure that I enable Docker BuildKit first. And now let's run this. Okay, so I build this Babel image. It's a kind of a cursed image because it has binaries for 4 different platforms. So what happens? Well, what happens is that we can successfully run the Intel 64 bits BusyBox. That one works. However, when we try to run the ARM versions, that just doesn't work. We get like this weird error because the Linux kernel is looking at this binary and it's like, go home, you're drunk, I can't execute that. And here I try to execute the Intel 32-bits version, and that works because one of the nice things with Intel is that you have this backward compatibility. So you can execute 32-bits program on a 64-bit CPU, and Linux has provisions to map the system calls, etc. Yay. Now, what happens if I go to this innocent-looking ARM machine that I have here? Yep, ARch64. And I go to my cursed Babel image, Docker buildkit 1. And then, yep, let's do that. So we build this image. And now we get exactly the opposite result, which is that the ARM 32 bits and 64 bits BusyBox will work because this is an ARM CPU and it also has backward compatibility to execute 32 bits binaries. However, if I try to execute the Intel binaries, now the kernel is telling me, no, I don't want to have anything to do with this. I don't want to execute these programs. Now, if you've been using Docker Desktop and if you have some Raspberry Pis laying around, you might have noticed or heard about the fact that Docker Desktop has some magic so that you can run images built for Raspberry Pis. Well, not just Raspberry Pis, but ARM in general. And same thing if you are the lucky owner of a recent like Apple Silicon machine, you probably noticed that most images just work. This works thanks to QEMU. And basically, okay, let me just check. Yes, there we are. So QEMU, I'm not going to do a full speech on QEMU, but it's awesome. QEMU is a very generic emulator. We can emulate like full machines with it, but it can also be used as a kind of system call translator for different architectures, kind of. So what that means is that you can take a Linux program meant for a different CPU, and QEMU is going to do the CPU emulation part, but when you have a system call, it's going to pass that to your local kernel. So instead of emulating a full machine, it's just going to translate the CPU part, and when you read a file or whatever, it's just going to do a normal open, read, write, etc. Now, to make that work, we combine that with something called BinFMT or maybe BinFMT, which is a way to register special programs with the kernel. So that's a way to tell the Linux kernel, hey, if you stumble upon a binary that looks like this, don't try to execute it directly because that won't work. Instead, hand it over to this QEMU thing and magic will happen. Other use cases for that include running DOS or Windows programs directly. Like you can register DOS programs with DOSBox. You can register Windows programs with Wine. You can register Java jar files with the JVM, etc., etc., so that then you can just run them obliviously, and the kernel will make it happen. So, and since with containers we like to make things easy for everyone, if you want to magically teach your kernel to run programs for different architectures, you can run this command here. So let's see, enable BinFMT, that's it. Okay, that's this little command right there. So what that does is that this is going to go and get this multi-arch QEMU user static image. So this image has all the QEMU bits that we need. And when I run this container, it's going to register all these translators basically. And there is a little trick here, which is the -- persistent thing. The -- persistent here means that it's going to keep a file descriptor open on all these interpreters, so that even when the container is gone, it will keep working. If you don't put that -- persistent flag, it won't work basically. Okay.
Gotcha.
Now that we've done that, I'm going to run my cursed image again. And now you can see that the Intel 64 and 32 bits work, and the ARM versions work as well. It was like, okay, like this is AArch64, this is ARM v7. So we just enabled this brave Intel machine to execute ARM binaries. Can we do that the other way around? Yes, we can. We will need a slightly different image because this multi-arch QEMU user static thing only supports Intel hosts. But if we use that one, it should work. And I don't think I put that one in my text files, so I'm going to have to actually, whoops. I'm going to have to actually type that. So docker run -- sorry, in that one, docker run -- run -- privileged. What else do I have? So aptman /qus /s/p. So the chunk, yes, I think so. All right, and so now if I run my cursed image, it works. Again, you can see that for the ARM binaries, it still works. And for the Intel binaries, now it was able to execute that correctly. So super useful, again, when you have an ARM machine and you want to use something that hasn't been built yet for your platform, or the other way around, when you want to build ARM images and you want to test them on your ARM machine. Big warning, this emulation technique is not 100% bulletproof. Treat that more like as a helper, almost like a crutch to test something, but I don't recommend that you run production workloads this way. Because there are some stuff may or may not work. Like I have some friends who have M1 silicon machines told me, for instance, that some versions of kubectl or Terraform just like randomly segfault when they use the emulation thingy, and so they make sure to use the right binaries. So just a little word of warning here. All right. Well, that's pretty much all I wanted to show as far as BuildKit features are involved. So yeah, to recap, that's
yeah. I was to say that was a lot. You want to? Yeah, go ahead. Recap, please. That was awesome.
So we saw how to get faster builds, thanks to parallel builds, but also thanks to selective, I don't know exactly how it's called officially, but selective copy. Like it doesn't need to upload the whole build context to run the build. We saw how we can use BuildKit to build on Kubernetes clusters. And we saw also how it helps with cross-compilation thanks to this build platform and target platform variables. And just in case, I had this as a kind of bonus thing because I don't know how long we're supposed to stay online here, but these little commands here are things you can use. Yeah, one thing I should mention is that on the Docker Hub and on other registries, you know, we have like the kind of historic image format, so to speak, where you have an image for one architecture, and then at some point we're like, okay, the world is not all Linux, Intel 64 bits. We have Windows, we have ARM, etc., etc. So we have a new image format, kind of. Well, it's not technically a new image format, but it's basically, I think it's called a FAT manifest, where basically when you get the image, the manifest for the image, instead of having like straight up the image manifest is going to tell you, hey, in fact, I do have this image available for different architectures. Which one would you like? And sometimes I wanted to kind of poke around and see which images and which architectures were available. So the little snippet that you have below will help you do that. The first thing here is something to obtain a token that will let you talk to the Docker Hub. And the one below then is like, okay, let's use that token to talk with the Docker Hub and get the manifest for a specific image. And yeah, that's it. Well, that's all I got.
Yeah, no,
I wish I could do
4 hours. We could spend all afternoon and do a big workshop and everything. No, that was fantastic. I mean, that's what I wanted to have you on, is just give a lot of folks an overview of BuildKit. Docker build in general. I love that the versions, and again, it's not internal versions, it's just the way Jerome was looking at the different versions, right? I thought we had it made when we had multi-stage builds, right, in V2, let's call it, right? And then BuildKit, right? I mean, just the caching alone and the copying of files, like you said, those two features are fabulous, right? We'll just speed up, make you more productive, like out of the box, right? Not a whole lot to do with it. It just turn on BuildKit. If you're not using desktop, it's on already, and just go, and it'll speed up your builds. They're more efficient. They're built in parallel. They also do, maybe you could talk real briefly, hierarchical kind of multi-stage build. So, you know, targeting a build, and what does it do? It goes and looks out, you know, walks the tree or something like that, right?
Yeah, my understanding of it, and like caveat, I haven't looked at the code, so this is just like my trying to guess, but
conceptually,
it looks like what it's doing, you know, instead of going through like linearly, it's going to go from the end, like the target that I'm trying to build, and then it's going to kind of compute a dependency tree. So if you have a plain old boring build, you have, let's say, 10 lines, and each line depends on the previous one. But when you have a multi-stage build, you could have this final thing that depends on that, and then you copy something from another stage, so you have this dependency like this. So it's a little bit like writing a makefile, where if you do an old style build, each makefile target depends on the previous one. But once you have a multi-stage build and you copy from other stages, now you have I think basically is it going to be a DAG or an actual? Well, anyway, you have a dependency graph, and what I've noticed is that when you look at the logs, the output of BuildKit, sometimes you see that it's trying to execute the copy from the other stage that is not over, and you see that it's kind of blocking on that copy. It's like, okay, now I need the output of that other stage, but that stage is not over, so you can see it's kind of blocked. And then it's going to, as soon as the other stage is over, it's going to continue there. So I suppose that it's building that dependency graph and then evaluating that.
Yeah, that's my understanding likewise. Right. Exactly. Awesome, man. Thank you so much. So Jerome gave us the repo. I think I put it in the chat. If not, I'm going to add it to the chat, and I'll add it to the description. So if you come back, if you're watching later, You're getting some shout outs here. Great presentation. Thanks, guys. Appreciate you joining and watching. So I will put the links in, but there's the repo and then the slides. Jerome shared slides with us. I know that's going to be hard. Hurry up, type that out before I take it off the screen. So no, I'll put it in the show notes so everybody can you can see the slides that Jerome used today. I know we went through them quick because we didn't want to take time of just going through every slide. More wanted to get more to the demos, but also to check out Jerome. He's on his main website. You can reach him there, or how about Twitter, right, Jerome? You're pretty active on Twitter. Can yell at you on Twitter there and getting some Twitter wars, or what do they call them? Flame wars, something? I don't know. But anyways, yeah, reach out to Jerome on Twitter, say hello. Yeah, awesome. Also, too, real quick, you can follow me on Twitter. Also, ask me some questions if you have any ideas. What content you would like to see on the show? Any topics? Any great guests you would like to see on? I'd love to hear from you. Reach out to me. One of the best ways to get in contact with Docker or get involved in our community is go to our community website. We have a list of meetups there. You can find local meetups if they're coming back online in your city. Also virtuals. We have a bunch of community events going on all around the world. Huge Docker community. Get plugged in. On that webpage too, you can find our Slack, our community Slack. So join our Slack. Jerome's in there. I'm in there. A lot of our engineers are in there. A lot of folks at Docker are in there. All of our captains are in there. They're super helpful. And then the community at large is in there. They're extremely helpful. They'll help answer your questions, get you pointed in the right direction. I already did the roadmap, but I always like to give the roadmap. So take a look at our roadmap. If you want to feature a feature request or just go in there and see what we're working on, please do so. You can interact with our engineers and our product folks through the roadmap, join in the discussion. We always like to get your feedback, understanding of how you're using our products, what's working, what's not working. That's one of the best places to do that. I think that's about it. Awesome. Thank you so much, Jerome. It's always a pleasure to talk to you. Always great talking to you. Always have great knowledge to share with our community. Thanks everybody for joining and watching. Come back next week. We'll have another live show on Thursday. Same time, same Batcave. We will be here. Thanks again, Jerome. Really appreciate it. Bye, everybody. Have a great evening and great weekend.